Hey everyone, welcome back to the GCSE Maths series. Today we're going to be looking at another key fundamental topic, Pythagoras Theorem. Something that is definitely almost guaranteed to come up into your exam. So let's lock in. Let's try and learn something today. Let's get straight into it. So, firstly, we're going to look at the key concepts behind the theorem and get your head around the formula needed, why we do it, how we do it. And then we're going to look at finding the hypotenuse, then look at finding a short side, and then obviously round off with some exam style questions. Finding the hypotenuse and finding the short side will make sense to you after we look in detail in section 1. So, looking at section 1, we need to see why Pythagoras theorem is used. So here we say that it is a formula used to find the lengths of sides in a right angled triangle. And a right angled triangle looks like this. And what makes this a right angled triangle is that it has one angle where two sides are perpendicular together. So this side and this side are perpendicular to each other. So, and it forms a right angle, and a right angle is obviously 90 degrees, as I'm sure you guys are aware. So the theorem states that a squared plus b squared is equal to c squared. Now you might be thinking, what has that got anything to do with our right angle triangle? Well, we label the sides of the triangle A, B, and C. And you might be thinking, okay, which one's called A, which one's called B, and which one's called C? So we always start off labeling the hypotenuse, the longest side, and obviously the longest side is obviously going to be opposite the right angle here, and we label this as C. And C is the hypotenuse. Always the hypotenuse, the longest side. Then A and B, as you can see in the first part of the formula, can be placed however you like with the remaining two shorter sides. So these two shorter sides are called the legs of the right angled triangle. Hence, we can literally call this one A, this one B, or vice versa. So now that we've got to grips a bit with the formula and how we label our right angled triangles, let's move on to the next section. So to find the hypotenuse, we can use our knowledge of the length of the two shorter sides and use Pythagoras' theorem to find the hypotenuse. Going back to here, our formula stated that a squared plus b squared is equal to our c squared, and we remember that c is always the hypotenuse and a and b, it does not matter in which order we arrange them. Hence, looking at question 1, we are told find the hypotenuse, a equals 3 centimeters, b equals 4 centimeters. The best way to do these types of questions is to draw out a right angled triangle, as so. And we are told that we need to find the hypotenuse, aka C, the longest side, always opposite the right angle. Okay, then, as we know, we can arrange A and B in whichever of the two ways we want to do it. We can just choose ourselves. So let's put 4 here and 3 here. Then, looking back at our formula, we know that A squared plus B squared is equal to C squared. But we want to find C. C is equal to the hypotenuse. So we use a squared plus b squared equals to c squared in order to get our c. So let's start off by putting 3 squared plus 4 squared is equal to c squared, which means 9 plus 16 is equal to 25, which is equal, c squared is equal to 25. Now, to get c from c squared, we must square root both sides of this equation. So c is equal to the root of 25, which is equal to 5. Hence, hypotenuse is equal to 5 centimeters. Okay. Moving on to question 2. We are told that A is 5 centimeters, B is 12 centimeters, and we need to find the C, we need to find our hypotenuse. So again, we're going to draw out our triangle. We're going to call this side B now, 12 centimeters, 5 centimeters here, and we need to work out our C. And the way we do this is our A squared plus B squared is equal to C squared. So 12 squared, oh actually no, that's wrong. Let's just do it this way. I mean, these are interchangeable completely, so it wasn't wrong, but in terms of the context of the question, perhaps you would want to write it in this way. So 5 squared plus 12 squared is equal to C squared. So we have 25 add 144 is equal to C squared. 144 add 25 is equal to 169, which is equal to C squared. Hence, the square root of 169 is equal to C. So C is equal to 13 centimeters. And you'll always notice that C, is going to be the largest out of the 3 lengths that you have on the triangle. Okay, moving on to question 3. We are told that A is equal to 7.5 centimeters, B is equal to 10.2. So let's draw this out again. This time we'll make this longer of the 2 shorter sides the base, and call this 10.2, and we'll call this 7.5. Utilizing our A squared plus B squared equals to C squared, we do 10.2 squared plus 7.5 squared is equal to our C squared. And notice how these are just interchangeable because we're just plussing. I've written 10.2 as B and just put B squared in front. It doesn't really matter which way you do that. So 10.2 squared add 7.5 squared is equal to 160.29, which is equal to C squared. Square root, if I was to do this to obtain C, is equal to 12.7 centimeters to 1 decimal place, as the question gave its measurements to 1 decimal place, so we'll just continue on that trend. So C is equal to 12.7 centimeters. Looking at question 4, we are told that A is 9.9 centimeters and B is 24.3 centimeters. So let's call this 24.3 centimeters and this 9.9 centimeters. Then A squared plus B squared equals to C squared, and we get our 9.9 squared add to our 24.3 squared is equal to our C squared. Hence, C squared is equal to 688.5, meaning C is equal to 26.2 centimeters. And yet again, we can see from our diagram 26.2 centimeters is longer than our 24.3 and our 9.9. Backing up the evidence that the hypotenuse should always be the longest side. Okay, let's move on to some challenge questions now. So this is more testing our ability to form equations. We looked at forming equations in a previous video. If you're a bit weak on this area, I'd advise you to go back and come back to this, or watch this and then go back to recap. So the base of a ladder is 6 meters from a wall. So let's draw our wall. We'll call this our wall here. The base of a ladder is 6 meters. 6 meters from the wall, and the ladder is 10 meters long. How high up the wall does the ladder reach. And hopefully you guys can see how we formed our right angle triangle. Our ladder is 10 meters in length and it starts 6 meters at the base of the ladder from the wall. So let's draw out our triangle to make it slightly more clear. We have our 10 meters here and our 6 meters here. Okay, so this type of question actually is not finding the hypotenuse, and I've made a mistake by putting this in this question, but we need to know this anyway. So as you can see, opposite the right angle, our C is already given, right? And we have one side, and we know the two shorter sides are flexible. We can rename them A or B. Hence, let's just call this one A. Let's go. And we need to work out B because we need to see how high up the wall does the ladder reach. And as you can see, this will be how high up the wall the ladder will reach. Okay. So, looking at our original equation, A squared plus B squared equals to C squared. We need an equation, and we need to rearrange our given equation to get it in terms of B, or in this case, B squared. So, we minus A squared from both sides and get B squared is equal to C squared minus A squared. And then we fill it in. B squared is equal to C squared, which is 10 squared, minus 6 squared, and that is 100 minus 36, obviously, which is B squared is equal to 64. Hence, B is equal to root 64, which is equal to 8. And our ladder reaches 8 meters up the wall. Okay, moving on. A square has a diagonal of 13 centimeters. A square, let's draw this out. That looks like a rectangle. Let's just fix this. A square has a diagonal of 13 centimeters, and a diagonal is going to be this one here. Each side is the same length. Use Pythagoras to find the length of one side. Okay, again, this is not finding the hypotenuse, and so obviously made another mistake in the questions. But yeah, it'd be interesting to look at. So we can isolate this square into two rectangles, two right angled triangles. Sorry, did I say rectangles? Okay. Now we can look at the bottom one and say that, okay, we know that each side is the same length, which makes this side equal to this side. So we can just call this A, and because they're equivalent, we can call this one A also. Hence, we can go into an equation and say A squared, where we would have used A squared plus B squared. We just put A squared plus A squared now, because B squared is going to be our A squared, is equal to our C squared, which is 13 squared. That is our hypotenuse opposite the right angle. Hence, collecting like terms, we get 2A squared is equal to 169. Divide both sides of the equation by 2 to get in terms of A squared. So 169 divided by 2 is equal to 84.5. Then square rooting both sides of our equation, we get square root 84.5, which is equal to 9.2 centimeters. Hence, this is the dimensions of our square, 9.2, and obviously we know from our laws that squares always have the same length no matter the side. Okay, now we're going to look at finding the shorter side, which is what we should have done, which is what we already started doing now. So as you can see, sometimes a right angle triangle, you're given the hypotenuse and one shorter side. You can use Pythagoras Theorem, but we have to reinvent the formula, rearrange the formula to get B squared equals C squared minus A squared. Okay, find the missing side. Let's draw out our right angle triangle. We have our 10 centimeters as our C, our hypotenuse. We'll call this side A, And then we need to work out the missing side here. So we use c squared equals to, no, not c squared. We can use the formula to say c squared minus a squared is equal to our b squared. This is our missing side here. So 10 squared minus 6 squared is equal to b squared, which is 100 minus 36, which is equal to 64. Hence, b is equal to 8. Okay, let's move on to the second question. Find the missing side. C is equal to 13, b is equal to 5. I'm just going to fly through these questions now because I think we're probably in a good space with them. We'll call this side 5 centimeters again, and we'll just say, to work out our a here, we'll say c squared minus b squared is equal to a squared. Hence, 13 squared minus 5 squared is equal to a squared. 169 minus 25 is equal to a squared. 169 minus 25 is 144 is equal to a squared, which means a is equal to square root of 144, which makes a equal to 12 centimeters. Hence, the missing side, a is equal to 12 centimeters. Okay. Looking at the intermediate questions, we can say that c is equal to 17 centimeters, a is equal to 8 centimeters, so 17 centimeters and 8 centimeters. Okay, so we have our c opposite our right angle. We say c squared minus our a squared gives us our b squared, and we say 17 squared minus 8 squared is equal to 17 squared minus 8 squared is equal to 225, and 225 is equal to b squared, which makes b equal to root 225, which is equal to, if we put that in on our calculator, is equal to 15. B is equal to 15 centimeters. Okay, I'm going to leave this question, number 2, intermediate, for you guys to have a go at, because I feel like we've done enough practice on it. I want you to apply your knowledge that you've learned here. And yeah, put your answers in the comments and I'll definitely get back to you with the correct answer. So, a slanted roof is 15 meters long. Slanted roof is 15 meters long. So a slanted roof would look like that and reaches 9 meters up from the ground. So it is 9 meters vertically up from the ground. How far is it horizontally across for the base of the roof? Hopefully you guys can see that we'll just do 15 squared minus our 9 squared, because this is our c opposite our right angle and we have a side here. To work out our b here, we'll just say this is equal to b squared. 15 squared minus 9 squared is equal to 144. Hence, b is equal to square root of 144, and this is equal to 12. So b is equal to 12 meters, not centimeters. Okay, looking at the final question today. A ladder is 13 meters long, and reaches 12 meters up a wall. So 12 meters up the wall, so 12 meters this way, and 13 meters long. We need to work out how far the base of the ladder is from the wall. So this is our wall. Obviously, we draw a right angle like that because the two lines meet at a perpendicular angle at 90 degrees. So we say this is our C. We'll call this angle, this side A, and we'll do 13 squared minus 12 squared is equal to our B squared. So 13 squared minus 12 squared is equal to 25, which makes B equal to the square root of 25, which is equal to 5. So the ladder is the base of the ladder is 5 meters away from the wall. Okay, that's going to conclude today's video. Hope you enjoyed the video. Hope you learned something. Please like, comment, and subscribe as always. It goes much appreciated, and I'll catch you guys in the next one. Peace.